Hi everyone, in today's lesson we are going to be covering on inverse proportion. So in the earlier videos in the SLS lesson, you would have some understanding about what inverse proportion is already. So in this segment of the video, we will be looking at some examples of how do we apply inverse proportion into various problems. We first take a look at practice now 8. In practice now 8, it says that a tank can be filled by 4 identical taps in 70 minutes. We want to find the time taken for 7 such taps to fill the same tank. So there are two things in the discussion over here. First is the number of taps, and the other is the time taken. We can draw a table, a rough table like this. It doesn't have to be a complete table with the title of number of taps and time taken. So at first the question says that there are 4 taps and then 70 minutes is taken. The question ends up wants us to actually find out, okay, 7 taps take how much time, right? So I noticed that I have left some space over here. That is for me to do my working. Okay, so our aim is to find out how much is the time taken. Alright, so it is easier if we can find out how much time is taken if there is 1 tap. So notice that there is a decrease in the number of taps, okay, and it is actually a division by 4. So 4 divided by 4 gives us 1. When there is a decrease in number of taps, do you think that it will take more time to fill up the tank or lesser time to fill up the tank? Okay, it should be more time to fill up the tank, right? So therefore, we will times 4 on the other side. So notice that there is an inverse proportion relation whereby we divide by 4 on the left, okay, but we times 4 on the right. Because logically speaking, when there is lesser text, it takes more time. So 70 times 4 will give us 280 minutes. Why is it that I do this by finding out what is the time taken for 1 tap? Because it is easier for us to then move from 1 tap to 7 taps, because I know that 1 times 7 gives me 7. So after finding 1 tap where I multiply by 7 to get 7 taps, with more taps I will take lesser time. So lesser time I will divide by 7 on the right side. Okay, so notice again the inverse proportion gives me a times over here and a divide over here. So therefore 280 divided by 7, that will give me 40 minutes. So therefore the time taken to for 7 such taps to fill the same tank is 40 minutes. Right? So very often when it comes to such questions, make sure that you check for the logicality of things. Okay, check whether you understand the question and it makes sense for the context of the question or not. Next, let's look at practice now 9 in your textbook page 172. You look at 9a only. Okay, in question 9a, it says that in 5 hours, 3 men can dig 2 identical trenches. Assuming that all the men work at the same rate, how long will it take 5 men to dig 7 such trenches? So there is some slight differences between practice now 9 and practice now 8. In practice now 8, right, notice that we have two quantities in discussion, which is the number of taps and the time taken. So there is only 2 quantities over here, or rather 2 variables. Okay, 2 things that will change. But as in this case, we have the time, 5 hours, we have the number of men, 3 men, and we have number of trenches. So in this case, there are 3 quantities, or we can say that there are 3 variables. So there's slight differences between practice now 8 and practice now 9. So in this question, we have our table drawn out with the heading of time taken, number of men, and number of trenches. So we start off with 5 hours, 3 men, 2 trenches. Then the question next goes on to ask how long will it take 5 men to dig 7 such trenches. So the end goal of our question is to find 5 men here and then 7 trenches. So we leave the gap in between our first line and the last line for us to do some working. So how do we go about solving this question? Okay, when it comes to 3 quantity, we can only change 2 quantities and keep the other one constant. Okay, so the skill here is that change 2 but keep 1. Okay, so what we can first do is to maybe find out 1 man, okay, so that we can then go on to find 5 men easily, right? Then if I want to find 1 man, okay, I need another quantity to change. The end goal of this question is to find out what is the time taken. So what we will do is to change the time taken, the amount of time taken. Okay, so notice that the number of men has decreased from 3 to 1. There is actually a division of 3. When I have lesser men to dig the trenches are like a hole. Okay, so if I have lesser men to dig the trenches, I will definitely need more time. So I will have to times 3 over here. And that will give me 15. So like I said earlier, we changed 2 quantities already, but I need to keep 1. So what do I mean by keeping 1? It means that I keep this as constant, the number of trenches as constant at 2. So I have changed this one, but I kept this the same. Okay, then from here, right, okay, I have already achieved the number of men to be 1 over here. Okay, I will next move on to maybe achieving 1 trench. Okay, so to get 1 trench, I'm going to take the original 2 trenches I divide by 2. Okay, I'm going to let that affect my time, which is here. Okay, because the end goal is to affect the time, right? So I'm not going to let it influence the number of men, right? So therefore, when I have lesser men, because I divided by 2, do you think it will take, sorry, I have lesser number of trenches, not lesser men. Okay, if I have lesser number of trenches to dig, will it take more time or will it take less time? I should take lesser time, right? Okay, so therefore, I will divide by 2 over here, and I will have 7.5. Okay, so divide by 2. Right, so I have already changed 2 quantities. I'm actually keeping the number of men constant at 1. Alright, now that I have achieved 1 over here and 1 over here, I will now proceed towards my goal of 5 men and 7 trenches. Right, so 1 man, if I'm going to let it become 5 men, that means I times 5. With more men, I will take lesser time. So sorry, with more men, I will take lesser time, yes. So therefore, I will take 7.5 divide by 5 and I will get 1.5. Okay, so since I've already changed 2 quantities, I keep here as a constant, which is 1. So now I have met the objective of 5 already. Okay, now the next thing that I need to meet the objective of is to get 7 for the number of trenches. So if I'm going to multiply by 7 over here, okay, if I have more trenches, I will definitely need more time. So therefore, I will times 7 on the left here, which is going to be 10.5. Okay, so I'm keeping the number of men constant. Right, so I have already met the goal of 5 men 107 trenches. So therefore, my answer is 10.5 hours. Alright, so since I've already met the goal, I can erase this part here. So the time taken is equals to 10.5 hours. Right? Next, we are going to be looking at chapter 7.5, where we understand algebraic and graphical representations of inverse proportion. Maybe before we jump into this example, just a very quick recap about what we learned that is similar to this topic about direct proportion. When it comes to direct proportion, when I say that some particular variable, let's represent it with a star, is directly proportional to, sorry, let me just edit this. When we say star is directly proportional to something else, let's maybe use a triangle to represent, I can form an equation that y is, sorry, not y, but star equals to k times triangle. So that's what we understood about direct proportion. We have also understood that the graph will be a straight line graph passing through the origin with my y-axis as my star and my x-axis as my triangle. So that is what we understood about direct proportion. Okay, so now we want to have a similar extension for the inverse proportion. Okay, so in inverse proportion, one example is as shown over here, where we have a discussion of speed and time. Notice that in this table, okay, as our speed actually increases from left to right, our time actually decreases from left to right. So this is a similar idea to inverse proportion. In fact, we want to be more precise about this. Okay, so speed and time is actually inversely proportionate to each other. Okay, so to be more precise, earlier on when we talk about direct proportion, there is this constant that we talk about. Okay, and this constant is always the same. Okay, a constant is something that remains unchanged. So in this table over here, okay, this second table, we want to find the product. Okay, so let's observe the product. So when speed is multiplied by the time, okay, that's what we mean by product, we will get 120 over here. Likewise, it is 120, 120. In fact, for every single value, okay, we will keep getting 120. So notice that the product, okay, of speed times time taken is actually a constant. It remains unchanged. In more particularly to this example, okay, speed and time, when we recall from what we learned in primary school, when I take speed to multiply with time, I'm actually getting the distance traveled. Okay, so the product is the distance traveled for this example. So what we see is that the product of x and y gives us a constant k. So in inverse proportion, x times y equals to k. Or in other words, I can also say that y is equals to k divided by x by doing some manipulation such that we make y the subject. So unlike how we saw direct proportion, whereby it is a y equals to kx form, in inverse proportion, we have y equals to k divided by x form. Now what about the graph? If I were to draw the graph with the time taken against the speed, okay, y against x, right? So my time taken is here, speed is here. Notice that the graph ends up being this shape, which is what we call a hyperbola. We will discuss more about such a shape when we go up to Z3 next year, but at this moment, we will just understand that for inverse proportion, this is the shape of the graph. This is very different from your direct proportion where you get a straight line, while in inverse proportion, you get this hyperbola, or in general, we can say that it is a curve. So the key concept over here is that when I say that y is inversely proportional to x, I can form an equation, and the equation could either be x times y equals to k or y equals to k times x. Typically, I will be using more of y equals to k divided by x, okay, instead of the other. Alright, so that there is some comparison to y equals to kx, which is on direct proportion. While for y equals to k divided by x is for inverse proportion. Okay, and then earlier on we have also mentioned that the graph of y against x is the hyperbola. So the hyperbola refers to this shape over here. Okay, and question 2. In this question, it says that if y is inversely proportional to x and y equals to 9 when x equals to 2, we want to find the value of y when x equals to 3. So we first capture the information here, that is y is inversely proportional to x. So that means that y will have to be equals to k divided by x, because that's the algebraic representation of inversely proportional. Okay, so then we need to find out what is the value of k. So we make use of the information that when x equals to 2, y is equals to 9. So we substitute y to be 9 equals to k divided by 2. So therefore k is equals to 9 times 2, which is equals to 18. So therefore y is equals to 18 divided by x. That will be the equation that represents this question. Okay, but that is not the end of the question. The question actually wants us to find the value of y when x is equals to 3. So therefore, when x equals to 3, we will substitute it into the equation. We get y equals to 18 divided by 3, and that leaves us with 6 as our answer. Alright. Moving on to the next question. Practice now 10, question 3. Again, we are looking at inverse proportion, which is n is inversely proportional to n. We want to copy and complete the table. So you may want to pause the video at this juncture to give this question a try before looking at how I go about explaining how to do this question. So since n is inversely proportional to m, we put that n is equals to k divided by m. So with n equals to k divided by m, we have a complete pair of information over here. So which is that m is equals to 2, n is equals to 2. Therefore, n equals to 2 equals, so we substitute it into, so when m equals to 2 and n equals to 2, we substitute it into the first equation that we had. So 2 equals to k divided by 2. Okay, so 2 is actually 2 divided by 1, right? We can see this as a fraction and a fraction, so we can cross multiply. Therefore, 2 times 2 equals to k. Hence, our k is equals to 4. And the equation that satisfies this question will be n equals to 4 divided by m. So with this n equals to 4 divided by m, I will be able to find out the solution for the remaining blanks of my table. So the first one, which is when m is equals to 0.5, my n will be equals to 4 divided by 0.5, and that would give me a 8. You could key that into your calculator. Okay, then we can find the next one, which is when n is equals to 4. So when n equals to 4, we have 4 equals to 4 divided by m. Okay, so we can cross multiply to get 4m equals to 4. And it tells me that m is equals to 4 over 4, and therefore I have 1. So therefore, This is 8 here, and this is 1 here. Okay, you can do the same thing for the remaining parts of the table. So I'll continue writing here for easier viewing. So when m is equals to 3, I will have n equals to 4 over 3. So that leaves us with 1 and 1/3. So 1 and 1/3. We leave our values to exact where possible instead of 3SF all the time. Then the last one, when n is equals to 0.8. So we have 0.8 equals to 4 divided by m. In other words, that is 0.8 times n equals to 4. So m is equals to 4 divided by 0.8. And that will give our answer to be 5. So our final table should be looking like this. We will now proceed to the last question of today's lesson, which is practice now 11. That's in your textbook, page 178. In this question, it says that the current I amperes, okay, in case you don't have this covered in your physics or in your science lesson, just want to briefly explain that current is a concept found in your physics or rather science lesson, okay, and it is represented by this symbol I. Okay, so current is represented by I. This A over here is the unit of current. Just like how your unit of your distance is usually your meters, kilometers, centimeter. So your unit of current is actually the capital letter A, right? But the letter to represent current is I. Okay, then it continues to say that the current flowing through a wire is inversely proportional to its resistance R. Okay, so resistance is being represented by the letter R, whereas the unit is ohms. Okay, so the unit is ohms for resistance. Then, continuing with the question, it says that given that the current flowing through a wire with a resistance of 0.5 ohms is 12 amperes, so 0.5 ohms is your resistance R, 12 amperes is your current I. Okay, we want to find the current flowing through the wire when its resistance is 3 ohms. Right? So coming to this, solving this part I, we need to first make use of the information, okay, from the understanding that it is inversely proportional. So inversely proportional, which is the current I, equals to K constant divided by resistance R. Okay, so this is the equation that we can form from the inverse proportion mentioned in the question. Okay, next we use the second piece of information, which is that I refers to 12 amperes. Let me change to a blue pen. 12 amperes. Okay, so when I is equals to 12, R is equals to 0.5. So 12 equals to K divided by 0.5. And therefore, K is equals to 12 times 0.5, or you can see it as a cross multiplication, that 12 times 0.5 equals to K. So K is equals to 6. So therefore, I is equals to 6 divided by R. So we have formed the equation here. Okay, so with I equals to 6 divided by R, we now see that our question wants us to find out what is the current flowing through when the resistance is 3 ohms. So that means that when R is equals to 3, we want to find the current I, which is 6 divided by 3, and that gives us 2. So therefore, the current, okay, equals to 2 amperes. Okay. For convenience, I'll continue on the left side. Looking at part 2, we now want to find out what is the resistance of the wire when the current is 3 amperes. So when current I is 3 amperes, using the equation I equals to 6 divided by R, we have I to be 3 equals to 6 divided by R. Cross multiply means that 3R equals to 6. Or in other words, R is equals to 6 divided by 3, and that gives us 2. So therefore, the resistance is equals to 2 ohms. Okay. We have come to the end of today's lesson. Please try out apply the concepts into the questions that are found in the SLS lessons. If you have any questions, please feel free to drop me an email or ask me during our next face-to-face lesson. Alright, so I'll see you again in the next lesson. Bye bye.